Students, we will discuss about fastener assembly in this session. The fastener assembly can be categorized into two: fixed fastener and floating fastener. Let us discuss about these two types of fastener assembly with an example. I have drawn a fan assembly partially. When you purchase a fan from the market, the blades are packed in a separate pack and the other parts of the fan are packed in a separate package. You have to open the pack containing the blades, then you have to fix it over to the rotor of the fan before it is hung over the hanger on the roof. You will be given sets of screws to fasten the blade over to the rotor of the fan. If you closely watch the blade, on the fan blade, clearance holes will be provided. On the rotating body of the fan, threaded holes will be present. You have to place the fan blade over the body, then you have to engage the screw with the hole so that the blade is fixed or fastened to the fan body. You can find that the screw is engaging with the thread on the fan body. So in a fixed fastener, this is a case of a fixed fastener. In a fixed fastener, any one of the parts to be fastened will have a threaded hole, while other part will have clearance hole. In this case, the fan blade is having clearance hole and the body is having threaded hole. A screw is used to fasten these two parts together. In case of a fixed fastener, any one of the part to be assembled will have thread, while the remaining part will have clearance hole. Now this is the example for floating fastener assembly. I have shown an electrical switch and a board. So when you purchase an electrical switch, you will be provided with the screws as well as nuts. You have to insert this electrical switch into the pocket of the board. Then you have to use the screws. The screws will engage with the holes on both the part. Then you have to engage the nut from the back side of the board. In case of a floating fastener, all the parts which are to be fastened together will have clearance hole. The clearance hole means it won't have thread. The size of the hole will be bigger than the body of the screw. So this is the example for floating fastener. In case of a floating fastener, all the parts to be fastened together will have clearance hole. You have to use screws and nuts to fasten the parts together. In case of a fixed fastener, there is no need for a nut because one of the part to be assembled will have a threaded hole. There is no need to use a nut for a fixed fastener. In case of a floating fastener, you need to use a nut because all the parts to be joined together will have clearance hole only. In this session, we will discuss about how to assign position tolerance to locate the holes on the parts to be joined together. Similarly, on this fixed fastener also, we have to decide Okay, how to fix the position tolerance for locating the holes on the parts to be joined together. The formula to be applied is shown. In case of a floating fastener, this formula is applicable. T1 is equal to H1 minus F. T2 is equal to H2 minus F. So what is T, what is H, what is F is shown here. F is the maximum diameter of the fastener, okay, or we can say the MMC size of the fastener. H is the minimum diameter of the clearance hole, or you can say MMC limit of the clearance hole. T is the position tolerance value. WC is the working clearance. So let us solve a problem using these equations. In case of a fixed fastener, the applicable equation is T1 plus T2 is equal to H minus F. So H is the MMC size of the clearance hole and F is the MMC size of the fastener. Let us solve this problem on floating fastener assembly. So you have three plates, plate 1, plate 2, plate 3. These three plates are to be fastened together using two sets of M12 bolts and nuts. On each plate, two numbers of clearance holes are present. We have to find the maximum permissible value of position tolerance applicable at MMC limit to locate the holes on each of the three plates. So this is the problem. We have to find the tolerances. The plate 1, plate 2, plate 3 are to be fastened together using two sets of M12 bolts and nuts. Plate 1 drawing is shown here. Plate 1, this is the front view of the plate 1, this is the top view. Two holes, two clearance holes are drilled to size of 12.5 H8. So these holes are located with reference to the bottom surface, which is datum C. Okay, so from the bottom surface, bottom edge, okay, this hole is located at 25 mm. Then the second hole is located at 50 mm from the other hole. On the other direction, the holes are located at 32 mm from the datum surface B. So we need to find out what is the maximum permissible value of position tolerance for locating the two holes on plate 1. Similarly, plate 2. So this is the drawing of the plate 2. This is the front view of the plate 2. This is the top view of the plate 2. The center to center distance has to be same on all the three plates. So here it is 50 mm. Here also it has to be 50 mm. Now what should be the maximum permissible position tolerance to locate the holes on plate 2? These holes are drilled to a size of 12.3 H8 on plate 2. On plate 3, the holes are drilled to a size of 12.4 H8. The center to center distance is same as 50 mm. So we have to apply the formula to find out the value of the position tolerance for plate 3, for plate 2 and for plate 1. So since it is a floating fastener, we have to apply this formula T is equal to H minus F for each of the plate. Let us apply this formula for the first plate. Plate 1, we will find out T1 is equal to H1 minus F. So for the first plate, the MMC size of the clearance hole is 12.5. Minus all the three plates are fastened together using M12 bolt and nut. The body of the M12 bolt will have an MMC size of 12 and it is having a LMC limit of 11.73. So since we have to use MMC size, you have to use the value of 12M, which is the MMC size of the fastener. So 0.5. Now on plate 1, the maximum value of position tolerance to locate the hole is found to be 0.5. For plate 2, the holes are drilled to a size of 12.3 H8. We have to apply the same formula again for plate 2. The plate 2 T2 is equal to H2 minus F. So the plate 2 contains clearance hole of size 12.3. This is the MMC size of the clearance hole on plate 2. Fastener is having the same size 12. So 0.3. So the maximum permissible value of position tolerance for locating the holes on plate 2 is 0.3. So we have to use a dia symbol. So now this is the tolerance on plate 2.3 is the maximum applicable value of position tolerance for the holes on plate 2 as per this equation. Plate 3. So plate 3 has holes drilled to a size of 12.4 H8. The MMC size of the hole is 12.4. The fastener's MMC size is 12.4. So on plate 3, the maximum permissible value of position tolerance for locating the hole is found to be 0.4 as per the equation. Let us look at another problem. These three plates which are discussed earlier are to be fastened together using M12 fasteners. Here we are going to consider a working clearance of 0.02 mm to arrive at the values of position tolerances. So the working clearance can be considered to account for any unaccounted error. So when you use this formula, or when we use this formula, T is equal to H minus F, this formula is not taking into account other geometrical errors like cylindricity of the holes. If you want to take into account this kind of unaccounted error, then it is better to consider a working clearance in the formula. So you are asked to include a working clearance of 0.02 mm to arrive at the values of position tolerances. So T1 plus working clearance is equal to H1 minus F to find the position tolerance on plate 1. So it is arrived as 0.48. Considering a working clearance of 0.02, the position tolerance for locating the hole on plate 1 is found to be 0.48. For plate 2, T2 plus working clearance is equal to S2 minus F. It is found to be 0.28. So these two holes are to be located with the position tolerance of 0.28 applicable at MMC limit. Plate 3. T3 plus working clearance is equal to H3 minus F. The T3 value is found to be 0.38. So the holes on plate 3 are to be located with the position tolerance of 0.38 applicable at MMC limit.